In this video, we are going to talk about dynamic polymorphism. But before I can tell you what is dynamic polymorphism, let me show you an problem first. Remember, we created in our employee library a developer class, and in that developer class, I had an issue with the calculate salary method. And the issue was that it is saying that calculate salary method of developer is hiding the inherited member employee calculate salary. Use the new keyword if hiding is intended. That means what? Let us understand that. In the employee class, already there was a calculate salary method, correct? And since I inherited developer class from employee, that's what brought that function here also, though I also have manually and explicitly written a calculate salary method because I knew the salary calculation will be different, isn't it? But that created a problem. The problem is that now when you call the calculate salary method from your application, the problem is here compiler is unable to exactly bind this calculate salary call as because in the Anil developer instance now there are two calculate salary method. Unlike the previous case where in the program.cs file we are creating an object of addition class and there are several add methods present in the same class itself, but there was a difference. Difference was in the signature, right? Either the number of arguments were different or the data type of arguments were different or the position of arguments were different. Somehow there was a difference and our application code was written in such a way that we are calling different add methods by passing different number of arguments or different data types of arguments, etc. C# compiler was able to make a difference between them, to figure out the difference between them and accordingly bind this method call to the particular method that we are intending to call, correct? But right now our problem is that when we call Anil developer.calculate salary, let me bring these two lines up and here it is, suppose say, okay, at that point of time, and also let me comment the remaining part here, we don't need it, correct, right now. So when you are trying to call this Anil developer.calculate salary, the problem is that the calculate salary, there are two present in developer. One is inherited from the base and another is a child, right? So what we are going to do right now is need to tell compiler, don't bother, invoke this child classes method and try to hide the base classes method by this child classes method so that one of the method is visible to the compiler. So what I can do is that I can use new keyword. Don't be surprised to see the new keyword which is used while creating an instance, which is a instruction to the runtime which says that create a new instance. Here it's slightly different. It says that this is a new another calculate salary method, has nothing to do with the base classes method. It is explicitly written as part of the developer. And now what will happen is that the warning is gone. The warning has been suppressed right now. But then from the program.cs, we'll be able to invoke the calculate salary method of the child class. As you can see from the output, it is going to invoke the child class method itself, which that's why you are able to see 10,000. Otherwise, if it calls the base classes method, then you will not get the incentive pay as part of the total salary, isn't it? That's what it is. So it told me to suppress that, that's fine, but then I have a slightly different problem. And that slightly different problem has something to do with our employee class. What? Let me explain that to you. It is quite possible that when you created an instance, say for example, this Anil developer over here, you created an instance, and that time you stored the reference in a variable of developer. You know, it's also quite possible to store the reference in employee too. Means, how come it's possible? Because it's not an employee instance? Yes, it's possible. As because it means that I'm declaring a variable of type employee and developer class instance which has been created here combines both the attributes and functionalities of employee plus the attributes and functionalities of developer. So that means in a developer instance, I do have, let me show you diagrammatically here also. Okay, so if consider that you have created a developer instance, so this is going to be your developer instance, and inside the developer instance there are two portions as if, two parts as if. This is the employee class related members and this is developer class related members as if, right? So consider in this way. So here, for example, say I have got employee name and other attributes, right? Other attributes plus this calculate salary function also. But whereas as part of the developer object, once again here I have got incentive pay, and the next one is again I have got a calculate salary, right? So practically this developer object is a combination of kind of two different things, though methods are not part of it exactly, but they are included as part of this class instance, because in the runtime the memory block allocation of the child instance does not include the function. Obviously function are not data, after all they are functionalities, so only the members will be included. But when you try to invoke calculate salary method, compiler will show warning as because there are two methods. One is by virtue of inheritance the developer instance has got, another is its own. So there is always a clash. Right now the fact is simply a developer instance is a combination of these two segments, isn't it? So it has got employee related attributes and functionalities, as well as it has got developer related attributes and functionalities also. So when I say that I declare a data variable of employee, of type employee, that is Anil developer, so what you can invoke via this, such as you can invoke now Anil developer dot calculate salary function. Suppose, say, for example, you are calling it here itself. I don't need to write the line once again. Calculate salary method. Let's have a look. Which method does it call? So I'm going to again do that line by line execution where you are creating an instance of developer class itself, which invokes the base class constructor, gets all these values assigned, then the remaining developers exclusive member assignment is also done. So now developer instance has been created combining two things, employee attributes plus the developer attributes, both of them, and also this instance has inherited a calculate salary function, has its own function calculate salary too. Now if I try to call calculate salary, look, surprisingly the call is going to the base class. That means you can see the file in focus is employee. So it's not invoking the actual objects method, but it's invoking the base class method as part of the child class right now, and that's why your salary unfortunately is going to be 8,000 instead of 10,000. 2,000 of incentive pay is not being included over there, which I passed via the constructor, isn't it? So what happens is simply I can conclude if I declare a variable of base type, I can invoke only base members, such as say, try one more time, Anil developer dot incentive pay does not appear in the intent instance as because though it is an instance of developer, but the reference variable is of type employee. So you can access any other properties which were originally part of employee now included as part of developer. Unfortunately, the developers exclusive properties, methods, data members cannot be accessed via this variable. That's all the point is. Okay. Right now I'm into a soup and I did not want it. I wanted always the method of the calculate salary method of the developer to invoke no matter whether I have declared a variable of employee or declared a variable of developer. I don't care about it. I just want that calculate salary method of the child class to be invoked, not the base class. Correct? By the way, if you create an instance of a child and store the reference in a variable of type base, this technique is known as upcasting. Upcasting. That means you have upcasted the reference to its base class. That's what is known as upcasting. If you do upcasting in C#, then you can access only the upcasted classes or the base classes types, base classes members like calculate salary and any other properties except the incentive pay, which is originally part of the developer instance. Right now in this kind of situation, what I don't want is to call these child classes method. Let me show you a real-time example where you can have this kind of situation where you need to do upcasting. Say, for example, you have created an object, right, developer, and also side by side, let me create another child class, say, for example, HR. So I'm going to add a class here by the name HR, and this HR class is going to be inheriting from, it's going to inherit from this employee class once again, okay, just like developer, but it will have its own data member, which say, for example, it has got gratuity payment, which is not part of developer, isn't it? So I'll have a constructor here which is situr, and that's going to be my default constructor, as well as I'm going to write another constructor which is going to include all of them. So here I say generate constructor and include select all. If I say only the classes member will be included, so what I'm going to do is I'm going to copy this constructor of employee and put it into HR here. Just change the constructor name from employee to HR and additionally include decimal gratuity payment as an argument so that it can be passed to this constructor and we get it assigned here also. So these dot uh, gratuity payment is equal to argument name gratuity payment. Now again, quite like the developer class, I'm going to use base keyword, and to that base keyword I'm going to pass employee uh, name and then employee ID, right? Then employee basic pay, employee DA pay, employee HRA pay. Then after that, the project name, whatever you have passed to me, that project name I'm bypassing, plus that birth year also I'm bypassing to the base type. So I don't need to write these unnecessary lines once again. I keep only this dot gratuity payment. And then for this one, let me have quickly here property which I'm going to click here and say encapsulate field but still use field, right? This is my property here, and I'm going to write that void calculate salary, ditto same method with the same name and the same signature here once again, where I'm going to say return. And before that, just a second, let me invoke that base dot calculate salary just like the developer class, and no return, sorry, I forgot that, these dot total salary plus equal to these dot gratuity payment. Does make sense, correct? So this is again showing this warning that you are trying to shadow the previous base classes method. So if you are intending to do that, nicely shadow it. But nicely shadowing it does not solve my problem. What happens again if I suppose here create in my main function, say I'm just going to create HR, HR is equal to new HR, and then I'm just going to copy and paste these values and make some changes here. Say for example, let's say the HR name is Sunil, ID is 101, and the basic is 2000, DA is 3000, HR is 4000, no project name, date of birth is 1989, and this one is going to be 5000 like that. Okay, these are my values over there that I'm passing. Now, where is the question of upcasting comes here? I can easily call Anil developer and maybe Sunil HR, right? The question of upcasting doesn't come here because I have declared a variable of the same class, and then I can easily call calculate salary. Suppose say I do not want to call the calculate salary and print this salary here. Say for example, for this I have a separate method as another static method. I'm declaring this method as a static because I do not want to create the instance of a program in order to call this method. I can simply from another static method call this static method. That's why void, suppose that this is my print salary method, and I want you to pass these references Anil developer Sunil HR here. What you can do quickly is that you know now by the time function overloading, so you can create a print salary method which will accept developer instance, and again you can create similarly here uh, same method print salary with HR and HR. Problem solved, right? Now you can call these methods from here, say for example print salary, and pass your Anil developer object here. No problem, as there is an overloaded function over here. And print salary, again you can pass Sunil HR also because there is an overloaded function for it. And most probably inside we are going to what we are going to do is that any developer instance you pass, we are going to call the calculate salary, and we are going to print console.writeLine the total salary here. So developer dot total salary, we can print it. Ditto same, we are going to do the same job here. So copy and paste it and make a change. This is going to be any HR and any HR. That means I can print. But now looks fine. There is no issue. Still, I don't face any problem with upcasting because I'm not going to do that anywhere. But look, tomorrow you come up with a new child class. Okay, again you are going to write this code here which goes against the small principle that in C# we follow, or in any object-oriented programming we follow, known as solid principle. One of it is open close principle. O stands for open close principle, in which I have told you earlier in previous of my videos that you should write code in such a way that it's open for extension, closed for change. So tomorrow I realize that I have got another child class, maybe say you have added another segment in your organization, say BPO employee, and now you have created that class and you have again implemented calculate salary. So you have to write here once again, you have to go back to your UI code and you have to write once again an overloaded print salary method which accepts BPO employee type of employee. And this is not exactly acceptable. So I wanted an one solution where there should be a print salary, though I'm not against it completely, but that actually goes against something kind of a principle. I want here such a print salary function to whom I can pass any kind of reference, be it developer, be it HR, be it a BPO employee, it doesn't matter to me, right? So that's what should happen. In that case, you can declare a variable of type employee, right? So, sorry, here it goes, employee and employee. So it could be any employee, and my job should be, let me copy and paste these codes here and make changes by uncommenting employee type dot calculate salary and employee dot total salary. If I wanted to solve my problem in this way, I could have written one print salary. I know upcasting, so any child reference can be passed to this variable. It can store a reference to a child instance, be it developer, HR, or BPO employee. I just want to call the calculate salary. I want to print the total salary. But in this case, I'll find the total salary is not expected, as because you yourself can calculate. It's supposed to be 10,000, which is coming as 8,000, and this is supposed to be around 13,000, which is coming as 11,000, isn't it? So why it's happening so? Because it's calling base classes method, as because in the child class instance there are two types of methods. One is calculate salary of base and calculate salary of its own. It's going to invoke the base, as because the reference variable is of type employee or the base. That's why. So this is where the problem I face. In order to solve this problem, I can tell you another way. Check out whether its reference is of type employee or not. And this you can do easily using employee is operator, and you can check if employee instance of actually type developer, that means employee stores a reference of a developer type instance. You can check this is operator is bound to return true or false. So is operator is applied on the reference types, not on the value types. First of all, that means if you have two variables like integer x is equal to 10 and integer y is equal to 20, you do not write over there if x is y, etc. It is supposed to check reference types, etc. So this will give you a compilation error. Okay, so it is not applied on the value types, it is applied on the reference type. It is supposed to check whether the reference variable stores that type of reference instance reference or not. That is why is operator is used. This is operator I have used here to check employee variable stores a developer instance reference or not. If it is so, I am going to do this. I am going to use developer, then developer, and then can write over there my employee, and I downcast this technique is known as downcasting. That means you are actually storing the reference which storing the reference of a developer instance which was initially stored in employee back to developer, and you are saying that as developer downcast it. It's quite equivalent of writing this line, which we know casting line, right? Developer employee. This is equivalent to the same, but then it can be used with value types and reference type both, where as operator can be used with just reference type, not with value type. That means you cannot write over there x as y like this. You cannot do that with reference value types. Here it means that you are taking the reference as stored in employee variable and down casting it, in the sense you are storing it back in a variable of developer type itself. So you need to downcast it explicitly, because employee has a capacity to store any reference. So you are exclusively mentioning that if it's of that type, then I'm downcasting is that type only. Okay, it has, understand, employee being a base, it can store either HR or developer. So you want to explicitly mention I want developer reference and to be stored in a separate variable, and then I can call this line developer.calculate salary, and then go ahead write this line console.writeLine developer.total salary also. But then again I have to write the similar kind of line one more time to check whether if employee is HR or not, and then I have to make these lines look like here HR as employee as HR, and then I have to make the call like HR dot calculate salary, and here also I have to write HR dot total salary. Now again, this could have been done, but then there is another problem. The problem is that again, then for each and every type, suppose you have a new BPO employee type, and the time right now you are writing the code, there are only two types of child classes, but then again, if you keep on adding child classes, you have to keep on adding if loop. This is again going against the open close principle. So I had two potential solutions. One, overloading the methods. Second, this kind of code where we check actual reference stored in employees of type developer or HR, accordingly downcast, and then invoke that specific method. But again, this goes against the open close principle. So this is what not I am looking at, isn't it? So this is your upcasting, where in this kind of situation we'll face a trouble, and the trouble is that if we do upcast, then we end up calling the base classes method rather than the child classes own method. So I do not want to change this code. Practically, even I do not want to write this code. In the meantime, you came to know about is and as operator in C sharp. But then this is what I want, and I want at any cost the method of the child class to be invoked. Doesn't matter whether the base class is like this. Correct? This is one of my problem. And the second thing is also I found that whenever I make a call to the developer.calculate etc., compiler is not sure which function is going to be called. And you can see, even though I have used new keyword in developer as well as HR, that's not solving my problem. It's not actually suppressing the base classes base classes calculate salary method with the help of child classes calculate salary method. It is just that it is the way to suppress the warning, to tell the compiler, if you want to bind it, go ahead. I am intending to call my child classes method. So now you should not have any problem. By chance, if you call Anil developer dot calculate salary method, that time there should not be any issue, as because now we have given an kind of go ahead to the compiler saying, I have hidden the base classes method of calculate salary by the developer classes calculate salary in the developer class, or the same applicable in case of HR class. So that's what you did, but the output didn't change. In case of upcasting, still you are ending up calling these base classes method, isn't it? So my situation is that different a base class might have a base implementation, but right now the child class, according to their necessity, would like to implement a new same function in a new way, right? So they want to take the same functionality, but they want to implement it in a new way. You can argue, obviously, if I do not want this kind of problem, I can change it to some other function name like developer calculate salary, HR calculate salary. Then there will be another problem. If you give them specific name, you don't end up with the problem, but you then end up with an unnecessarily having a calculate salary method over there in each and every class, where each and every class can have their own method. And second is that in program.cs file, you can no longer write employee.calculate salary as, because you do not know whether employee means which method each and every child class do have. So you will be forced to write this code where you have to first of all check the type of instance, and then downcast, and then call developer.developer calculate salary method, and then HR.HR calculate salary method, because they are not common amongst all the child class. So what is the agenda of this kind of pattern is that in base class I want the common functionality. Now the same common functionality should be part of every child class, but then child class has a flexibility to provide their own implementation. Correct? That's what is the idea of this design pattern here, which says once again the child class, sorry, a parent class will have everything common, but then child class will take this common and can implement. But we end up with a different problem here in C sharp that says now if you have upcasted, you can only invoke base classes member, not the child classes. So this is my situation where I want that best child classes method should be particularly invoked. By the way, this is something called a dynamic polymorphism you are looking at. That means base class has a method which is inherited by child class and provided a new implementation. Now when you use in your code a particular type of reference variable, either base classes method is invoked or child classes method is invoked, but then both base and child have the same functionality, so polymorphism calculates salary. But why dynamic? As because right now which function will be called will be decided during the runtime depending on the type of variable here. If you have upcasted employee type it is, then employees calculate salary will be invoked. If you have not done that and you are calling on the child class variable itself, then the child classes function will be invoked, isn't it? That's what is a dynamic polymorphism. First thing, that means these polymorph functionality will be invoked obviously during runtime, not during compile time, but the decision of which functionality, the base classes functionality or the child classes functionality will be invoked is decided during runtime. Not only that, in this way, we can decide which function and which type of instance you have created and which functionality can be invoked. But there is one problem right now I'm facing, and that is I didn't want these employee related function to be invoked. I wanted developer. That's what the actual nature of dynamic polymorphism. So if I created a developer instance, I want badly developers calculate salary to be called. If I have created HR's instance, then HR calculate salary to be called. So during the runtime, what type of instance you have created, that particular type calculate salary function to be called, not the base class. That's actually dynamic polymorphism, right? In order to solve this issue, C# provides you a fantastic technique. It says in that base class, declare your base class method with virtual function, and in the child class, now forget about the new keyword. You saw it was just to avoid warning. In the child class, you use override keyword. No question of using new keyword anymore because it does the same job. But override keywords does one more extra thing, as because it helps you to invoke the child class's own method rather than the parent class's method. So that's what is dynamic polymorphism here. I should do the same for HR also. Here also I'll keep this code for you. Sorry, I just cut it. So, and make a change and say override. Okay, so this override keyword, what it will do, it will give an extra instruction to the runtime saying, you are supposed to call, in this situation, you are supposed to call base classes calculate salary method. Don't. It tells the runtime to go back to the child class instance and invoke the child class's explicit function here, such as in case of developer, overridden calculate salary method, or in case of HR, its own overridden calculate salary method. That means at that point of time, runtime to runtime, you should make this employee like a virtual as if it does not exist, so that it can invoke each and the developer's own functionality. Right now, if you look at your code and try to run it, you will get back your proper salary as expected, 10,000 and 16,000. Sorry, my mistake, not 13,000, 16,000, as I think I passed 5,000 over there, right? Yep. So this is how virtual and override keyword works to help you with the dynamic polymorphism. And now that's proper dynamic polymorphism. So I created developer instance or I created HR instance. During runtime, depending on which instance you have created, that particular type's functionality will be invoked no matter you have upcasted or not. Okay, this is what is dynamic polymorphism, and C# achieves it via using virtual keyword and override keyword. Do you understand? Virtual must be used with the base type same function, and override should be used with the child type same functionality. Override keyword does not exist without the virtual keyword. So if you delete this virtual keyword, it does not know what to override. So in the developer, it shows already that calculate salary of developer cannot override inherited member as it's not marked as virtual abstract or override. So simple thing, I'm going to make it virtual as it was again, right? But look at this again, developers means override keyword is optional. That means if you tend to override, go ahead override, or else leave it, not a problem. So virtual does not force you to use override keyword, but if you want to use override keyword, you must have this virtual keyword here. Okay, so this is how virtual override works. And if I run this application, as you can see, you are getting the proper output. My upcasting problem is also solved, and now I can have this code nicely that the print salary doesn't matter whatever employee is coming up, depending on the actual instance type, it can invoke that instance's method or that type's exclusive calculate salary method or the overridden calculate salary method. So it's an extra instruction to the runtime which goes towards the developer instance and invoke its own exclusive method rather than the parent class's method. isn't it? Now, there are certain twists and turns that I'll show you through a slightly different example here, and that is that even junior developer, I think I made this class SIL, so I'm just going to remove it, and you can see I just created one class by the name junior developer, right? In that junior developer, I can again go ahead and override this calculate salary method. And how did I do it? Let me show you here. I just type public and then override and then I pressed spacebar in your laptop or the desktop, and immediately Visual Studio shows these are the overridable members, means these members of the base class have been declared with virtual keyword or some other keyword. You will see later point of time abstract or override keyword also. That's what I'm about to discuss, one of them. Okay, so you can select this calculate salary by pressing down arrow key and then hit enter key or tab, whatever you like. You will immediately get the complete signature because you are supposed to override the same functionality. So the function name must be same, the signature must be same, right? Now that's why base.calculate salary is a default line that Visual Studio adds, and you can go ahead and can change it. Say for example, junior developer has some extra data member, and you can include into the calculation and can provide a new implementation to the calculate salary. But notice this is the child class which is overriding its previous base classes already overridden methods. That means override keyword is applicable with a child class when the immediate base class has either virtual or override keyword. That means if immediate base class has override keyword, no doubt there is up higher the chain, there is a virtual method somewhere which this immediate base class is overriding. So override keyword can be used with a child class functionality under the condition number one, if the base class method is virtual or immediate base class method is overridden, that means there is some other base class which has got obviously up in the chain in the multi-level inheritance there is a base class, and that that developer class has already overridden that, and that is declared with the virtual keyword. So override keyword once again can be applied in two situations, actually not two, in three. The third one you will see later. Right now override keyword can be used if the immediate base class has either virtual keyword that you can override in the child or already overridden some virtual method, that means immediate base class has an override keyword with it. In these two situations as of now override keyword can be used. Okay, so this is what is the hierarchy of virtual and override, correct? So in another video we are going to talk about this third situation where we can use the override keyword with something called abstract keyword, but that's known as abstract pattern, and we are supposed to learn about abstract class. So let's see. Let's make a conclusion here. So there are two types of polymorphism we came to know. One is compile time polymorphism, another is runtime polymorphism. And in case of runtime polymorphism, a great example is that function overriding. That case, you need to understand, in case of runtime polymorphism, there are two classes involved, like two classes involved, right? So those two classes are, one is there is a parent and there is a child involved. But then the question of overriding comes because the parent has a method which child wants to override, and I want every time depending on the what kind of instance I have created, that particular functionality should be invoked. Whereas in case of compile time polymorphism, you will notice the operator, overloaded operators and overloaded functions, they exist in the same class. So there is only one class involved in which we write all the overloaded operator or operator overloading functions and the overloaded functions in case of function overloading, as you can see in the add function. All of them are present in the addition class. But here two classes are involved. That's where the question comes, whether this function or this function, child's function or the parent's function to be invoked. Or even we solve this problem, the fact is at different point of time we have many child classes, so whichever child class instance has been created, that particular child classes function should be invoked, right? This is what is dynamic polymorphism. Understand, in case of compile time polymorphism, it is easier for compiler to figure out which of these overloaded operator or function to be invoked, as there is a signature difference over there, right? But in case of runtime polymorphism, the parent and child have ditto same methods, no difference in the signature, the name is same, number of arguments, data type of arguments and position of arguments all will be same. Then the question comes, how compiler is going to distinguish between two different functionalities of parent and child, right? At that point of time we tell them using this override and virtual keyword to say which function will be invoked during runtime, which child classes function will be invoked runtime, and also to say that the decision of first of all binding the functionality, the function call with the function itself will be done during the runtime as well as it will be invoked during the runtime. That's why it is known as runtime polymorphism. These are the two types of polymorphism we came to know till now, and in the next video we are going to talk more about this virtual and override keyword. You will find out with something called abstract class, abstract pattern also. Okay, so that's it for this video. You came to know about polymorphism in these three videos altogether.